Chapter 14, calculations with ratio and percent strengths. Let's take a brief second, go over these keywords really quick. Medication strength is the concentration of active ingredient in a medication. Percent strength is the amount of active ingredient per 100 parts total. So X over 100 would be equal to X percent. QS is quantity sufficient or required. QSAD is quantity sufficient to make. Ratio strength is the expression of strength of weak solutions or liquid preparations, 1 part active ingredient, X parts total. The solute is the smaller portion of a solution, the component to be dissolved in the solvent, and the solvent is the larger portion of a solution, the component doing the dissolving, aka diluent. If you're comfortable with the material, you can go ahead and do this pre-test to test yourself. If not, return after reading the chapter and performing some problems. So percentage and ratio strengths are two additional methods for expressing medication strength. The amount of concentration of active ingredient present in medications. When the solute or active ingredient is described as part of the total amount of preparation, the resultant product may be expressed in percent strength or ratio strength. Both express an amount of medication per unit of volume or weight of a total liquid or solid preparation. These medication labels express the percentage strength, such as lidocaine 1%, or the ratio strength, such as epinephrine 1 to 1,000. Ratio strengths are usually used for liquid medications with a very low concentration of active ingredient. Percent strengths are used to express some medications, as well as to express the amount of solutes in any pre-made intravenous solutions. So percentage strength is always interpreted as an amount out of 100. It is used to describe various solutions and topically applied drugs. There are 3 basic types. So we have weight and volume, which is WV, and that is going to be X grams over 100 ml. Volume and volume, VV, X milliliters over 100 ml. And weight, WW, X grams over 100 grams. All right, and we will go over that throughout the practice problems we do. The ingredients found in prepared intravenous fluids such as dextrose or sodium chloride are expressed in percentage strength. These fluids are labeled with the percentage of solute found in the total solution. D5W or 5% dextrose in water indicates that 5% dextrose is present in the total solution with water as the solvent. Remember, the percentage is always based on 100, so the percentage is shown per 100 ml of solution, indicating that 5 grams of dextrose is found in 100 ml of fluid. However, if the solution is larger than 100 ml, the total weight of the solute must be calculated. Table 14.1 gives some good abbreviations for common intravenous solutions. So NS normal saline is always going to be 0.9%. Half normal saline is going to be 0.45%, which is exactly half of 0.9. D5W is dextrose 5% water. So D10W is dextrose 10% in water. And then D20W and D50W and so on and so forth. D5LR is dextrose 5% in lactated ringers. And so on and so forth. We'll go ahead and do example 14.1. Example 14.1, a physician orders 500 ml of D5W for a patient. What is the weight in grams of dextrose in this bag of fluids? So we have this D5W, so that's our percent, 5%. And we are going to rewrite it as 5 grams over 100 ml. And this is a weight volume problem. So now I'm going to use this here. So 5% is essentially 5 grams over 100 ml. That's the strength. Do a proportion. And then on the other side, I'll plug in that 500 ml. And I'm trying to find out what is the weight in grams. So X grams, that makes sense. So 100X is equal to 5 times 500. And then we'll do the 5 times 500 first. which is 2,500. So we have 100x is equal to 2,500. We want to get the x alone. So we need to get rid of this 100 here and also divide it by 100 there. And we get 25 grams. So there's 25 grams in the bag of fluids. How many milligrams of sodium chloride are in 250 ml of normal saline? Normal saline is 0.9% sodium chloride, so the known information is 0.9 grams over 100 ml total solution. So this is giving it to you already. What we just did in the previous example, it's giving you the conversion factor. So normal saline is 0.9 grams over 100 ml. And we have 250 ml. How many grams is needed? Now, this question is asking for milligrams, but we can convert that at the end. So 100x is equal to 0.9 times 250. So it's 225. So 100x equals 225. We want to get rid of that 100, so we have x alone. So 225 divided by 100. It's going to give us 2.25 grams. Now we need to turn that into milligrams. So we're going to use the conversion factor to convert milligrams to grams and grams to milligrams. 1 gram equals 1,000 milligrams. So I'll place that in one side of a proportion. And then on top, I'll add my 2.25 grams. Find out how many milligrams. So I would do 1x is equal to 2.25 times 1,000. So x is kind of already alone, not kind of, it is already alone. So we're just going to do 2.25 times 1,000, and that will give us our answer, which is 2,250 milligrams. So make sure you're paying attention to what they're asking. A physician orders 500 ml of 5.5% Travostol, which is amino acids, to be used in a total parenteral nutrition bag. How many grams of amino acids will be provided? So we have that percentage of 5.5%. We have weight and volume in the problem, so we know that this is going to be 5.5 grams over 100 ml. And then we just simply do 5.5 grams over 100 ml, which is equal to 500 ml. And we want to know how many grams. So 100x is equal to 5.5 times 500. So 5.5 times 500, which is 2750. So 100x equals 2750, and we want to get x alone, so we're going to divide each side by 100. $27.5 grams. Percentages are also used for some liquid and semi-solid medications to show different strengths, such as 1% lidocaine. Let's just go ahead and do 14.4. Example 14.4. So interpret the following medication: 15% neomycin solution, weight volume. So what that means, and this is what we're interpreting it as, 15 grams of neomycin in every 100 ml of total solution. How many grams of neomycin are in 200 ml of total solution? So we're taking that 15%, and that is 15 grams over 100 ml. It's weight volume. Really see that ml there. All right, so on one side of the proportion, I'm going to do 15 grams over 100 ml. And then on this side, I'm going to plug in that 200 ml. How many grams? So 100x is equal to 15 times 200. So 15 times 200 is 3,000. Now we want to get x alone, so we have to divide it by 100. That crosses out. We have x by itself now, but we have to do 3,000 divided by 100 to get our answer of 30. So we need 30 grams to make 200 ml, which makes sense because before we were doing 15 grams and 100 ml. So if we were doing double the amount of liquid, we would obviously need double the amount of neomycin. Next, how many milligrams of neomycin are in 4 ounces of 15% solution? So we have to do a conversion. So remember, 1 ounce is equal to 30 ml. Another important one I would always know. So I'll do that here. And I'll plug in my 4 ounces. How many ml is that? So we would do 1x, which is just x, and then 4 times 30. 120. So that's 120 ml. So we had to do that before we could even begin to start the problem. So now we can use that to figure out our answer. So we're gonna do just like we did in the above one. On one side is gonna be the strength of the neomycin, which is 15 grams over 100 ml. And now we want to make 120 ml. How many grams do we need? Now just pay attention to the fact that this is only slightly more than what the original amount is. So our answer should only be slightly more as well. So we have 100x is equal to 15 times 120. So 120 times 15 is 1,800. Now we want to get x alone, so we need to get rid of that 100. And then we also have to divide 1,800, the other side, by the same as well. So that gives us 18 grams, which makes sense, just slightly more than 15 grams. So what is the strength in milligrams per milliliter? So we have to convert that 18 grams to milligrams. So 1 gram is equal to 1,000 milligrams. We have 18 grams. How many milligrams? So this would be 1x, which is just x, is equal to 18 times 1,000. So 18 times 1,000 is 18,000. So 18,000 milligrams per 120 ml. Now we need to see if we can get rid of some of that. So let's divide 18,000 divided by 120. And that gives us 150. So we divide both of them by 120. we now have 150 milligrams over 1 ml. So just ml. All right, now how much neomycin powder is needed to make 50 ml of 15% solution? So you can kind of see here what we are doing with these percentages now. So our 15% is 15 grams over 100 ml. This time we want to make 50 ml. How many grams? So we would do 100x is equal to 15 times 50. So 15 times 50 is 750. We want to get x alone, so we need to divide each side by 100. We got x alone, now we have to divide each side by 100 to make it even. So 750 divided by 100 is 7.5 grams. All right, so next, a physician orders 3,000 ml of 15% neomycin solution to use for irrigation of a wound. The available neomycin is 0.5 gram tablets. How many grams of neomycin are needed to fulfill the order? Right. So our 15% of course is 15 grams over 100 ml. We need to make 3,000 ml. How many grams do we need to fulfill the order? So this would be 100x is equal to 15 times 3,000. So 15 times 3,000 is 45,000. All right, you want to get x alone, so we got to get rid of this 100. We also have to divide this side by 100, which is going to give us 450 grams. And if we have, how many tablets are needed? So if 1 gram, or I'm sorry, if 1 tablet is equal to 0.5 grams, and we have 450 grams, how many tablets do we need? So this would be 0.5x is equal to 1 times 450, which is just 450. Now we want to get x alone, so we'll divide each side by 0.5. And 450 divided by 0.5 is 900 tablets. Example 14.5, how many milliliters of D50W should be administered to a hypoglycemic patient to provide 150 milligrams of dextrose? So first we're going to take that 50% and we're going to rewrite it as 50 grams over 100 ml. Our problem, however, has, excuse me, 150 milligrams. So we need to convert that 50 grams to milligrams. So we're going to use the conversion factor of 1 gram is equal to 1,000 milligrams. And we're going to plug in our 50 grams here, and this will be our x milligrams. All right, so now we need to cross multiply. So we have 1x is equal to 50 times 1,000. So we'll do the 50 times 1,000 first. Which is 50,000. And that's our answer because this is already at 1. So 50,000 milligrams, and let me erase that so no one thinks that's super important. And then we have to plug that into the problem now. So we have the strength as 50,000 milligrams over 100 ml. And we need the same units on top and bottom as we do as the other side of the proportion. And then we can plug in that 150 milligrams to find out how many ml of dextrose we need to provide 150 milligrams. So for this one, we're gonna do 50,000 x is equal to 150 times 100. So we'll multiply 150 times 100. And we get 15,000. And then over here we have still 50,000 x. We want to get x alone, so we need to divide this side by 50,000. Now we have x by itself, but we also have to do that over here. So 15,000 divided by 50,000 is going to give us 0.3 ml. Example 14.6, how many milliliters of 15% neomycin solution can be made from 150 grams of neomycin? So of course we're working with percent, so we're gonna take that 15% and turn it into 15 grams over 100 ml. So you can see that the weight volume problems are the ones we use the most. And then I'm just gonna simply do a proportion using that on one side. And then I have 150 grams. It's asking me how many milliliters, so this makes sense. Now I'm gonna cross multiply. So 15x is equal to 100 times 150. And we'll do 100 times 150, which is 15,000. And we have 15x here. Still, we want to get that x alone, so we need to get rid of the 15. So we'll divide each side by 15. So 15,000 divided by 15 is 1,000. And that's 1,000 milliliters. So we can make 1,000 milliliters of 15% solution from 150 grams of neomycin. So types of ratio strength, the numerical amount of active ingredient in ratio strength is always 1. Ratio strength is expressed as 1 to x, with x representing the total amount of product. So we already kind of talked about this in the beginning of this chapter, but we have those 3 different types. So we have 1 gram to x ml for weight and volume. In volume to volume, we have 1 ml to x ml, and weight to weight, we have 1 gram to x gram. So we have example 14.7, interpret the following 1 to 1000 sodium bicarbonate solution. And we're gonna interpret that to 1 gram of sodium bicarbonate in each 1000 milliliters of total solution. And how many grams of sodium bicarbonate are in 300 ml of a 1 to 1000 sodium bicarbonate solution? So now we can do our math. Give ourselves some room here. Okay. So we're gonna use that ratio, which it gave us basically the strength, 1 gram over 1000 ml. And we want to know how many grams, so X grams are in 300 ml. So we're going to do 1000X is equal to 1 times 300, which is 300. We'll carry that down. We want to get X alone, so we need to get rid of that 1000. So we do that by dividing by it and getting rid of it. So we have X. Then we also need to divide that other side by 1000. So we would do 300 divided by 1000, which is going to give us 0.3 grams. Now it's asking what is the strength in milligrams per ml. So we need to convert that grams to milligrams. So we're going to use the conversion factor of 1 gram equals 1000 milligrams. So I'll place that on one side of the proportion. And then I'll use my 0.3 grams to find out how many milligrams. So this would be 1x, which is just x, times 0.3 times 1000. So once we do the 0.3 times 1000, that is going to be our x. And that is 300. So that means x is equal to 300 milligrams. So our strength is 300 milligrams slash 1000. Or sorry, 300 milligrams over 300 ml. So then we have 300 milligrams per 300 ml. So that is technically the strength, but we can further reduce that by 300 and 300 going to each other once. So our strength is technically 1 milligram per 1 ml. A physician orders 75 milliliters of a 1 to 15 sodium hypochlorite solution to be used in the office. How many grams of sodium hypochlorite are needed to prepare this solution? All right, so the sodium bicarbonate is really 1 gram over 15 ml. And we have 75 ml. How many grams are needed? So we would do 15x is equal to 1 times 75, which is just 75. And we want to get x alone, so we need to get rid of that 15 on this side. And then we also have to divide that side by 15 as well. So that is going to give us 5 grams. And then that's the answer to here, but then how many milliliters of solvent are needed? How many milliliters of solvent are needed? Well, we're making 75 ml. So at the end, after we put in our sodium hypochlorite, we're gonna bring our final amount up to 75 ml. So we don't have an exact amount for that, so we're just gonna say QS 75 ml. How many milliliters of epinephrine 1 to 1,000 solution are needed to provide a 0.5 milligram IM dose? So that 1 to 1,000 means that we have, of course, 1 gram over 1,000 ml. And we want to find out how much is needed for 0.5 milligrams. So that means we need to convert this 1 gram to milligrams. So we can easily do this because we know that 1 gram is equal to 1,000 milligrams. By now we have that in our brain and we know that. So we're gonna say 1,000 milligrams over 1,000 ml. And we wanna give 0.5 milligrams, how many ml? So we would do 1,000x is equal to 1,000 times 0.5. So 1,000 times 0.5 is 500. Still gonna carry my 1,000 down here. Now I need to get rid of that 1,000 because I want to get x alone. So to do that, I'm going to divide both sides by the 1,000. I get x alone here. And 500 divided by 1,000 is 0.5 milliliters. Now, this is kind of nice because this is a perfect example of two different sets of numbers being exactly equal. So we have 1,000 milligrams over 1,000 ml on one side. So that means on the other side, per proportion rules, you're going to have the same number on the bottom. So we just did the math and we figured it out, but also you could just look at that and say, well, if I have 1,000, the same two numbers on this side, I have to have the same two numbers on this side as well. So 0.5, I always recommend doing the math though, never ever just thinking you see that in your head. For example 14.10, what ratio strength solution is found by dissolving Benadryl 50 milligrams in a lotion to make 150 milliliters? So we first need to change 50 milligrams to 0.05 grams, which has already been done. So we're gonna do 0 0.05 grams over 150 ml. And our ratio strength is technically 0.05 grams to 150 ml, but we just want to make sure we bring it down to the lowest terms. So I'm going to start off by dividing 150 by 0.05, which gives us 1,000. So if I went into each one by 0.05, I now have 1 gram. And 150 divided by 0.05 is 3,000 ml. So our strength is going to be 1 to 3,000. Changing from ratio to percent strength. Set up a ratio and proportion that asks the question, if there is 1 part active ingredient, X parts total preparation, how many parts of active ingredient would be in 100 parts of total preparation? So let's go ahead and do example 14.11. What is the percent strength of a 1 to 10,000 weight volume solution? If there is 1 gram active ingredient in 10,000 ml, how many grams would be in 100 ml? So we're gonna rewrite that 1 gram over 10,000 ml. And we want to know how many grams are in 100 ml. So we're gonna rewrite it. Do a proportion, so 10,000 x is equal to 1 times 100, which is just 100. And we want to get the x alone, so to do that, we are going to divide each side by 10,000 to get rid of it. So I just have x here. And 100 divided by 10,000 is 0.01. Now, because we already figured out over 100 ml, which is where percent comes from, so that's why we are finding out the 100 ml, because we're trying to find the percent strength. Our percent strength is 0.01%. That's all you do for that. Well, what is the percent strength of a 1 to 200 ointment? If there is 1 gram of active ingredient and 200 grams of total, how many grams would be in 100 grams? So this is weight, meaning we're gonna have grams on all 4 sides. So on one side of our proportion, we're gonna put the strength using that ratio. So 1 gram over 200 grams. So because there's 1 gram of active ingredient, 200 total, and we want to know how many grams would be in 100 grams. And then this grams would be our X. And if you were unsure of, well, how would I know which one to put it under because I have grams on both sides? Well, we want to know how much is in 100 gram, which a percent strength, and that is the total. So the total would be on the bottom. So we'll start off by doing 200x is equal to 1 times 100. We know 1 times 100 is 100. We carry our 200x down. So just like all the other problems, we want to get x alone. So we're going to get rid of it by dividing each side by 200. So 100 divided by 200 is going to give us 0.5. Since this is already over 100, our answer is 0.5%. That is the percent strength. Example 14.3. What is the percent strength of a 1 to 5,000 preparation? So this is what sometimes throws students off because they're like, wait, all the other ones told me what to do. So this one's not telling you what to do. But whenever it asks for percent strength, it's always got to be out of 100 because that's the highest a percent can go. So we have on this side 1 gram over 5,000 ml. We'll say. At this point, wouldn't matter if I did 1 gram over 5,000 grams because we're just taking that top number off of this side to find out the percent strength. So we would do 5,000 x is equal to 1 times 100, which is 100. And we have 5,000. So we want to get x alone. So we're going to divide each side by the 5,000. So that is going to give us 0.02%. That is the percent strength of a 1 to 5,000 preparation. Changing from percentage to ratio strength, set up an RMP that asks the questions if there are X parts active ingredient, 100 parts total preparation, 1 part active ingredient would be in how much total preparation. And let's do these examples. Example 14.14, what is the ratio strength of a 0.04% weight volume solution? So remember, like we did in the other problems, those were the percentages were always out of 100. So this is telling us that the top of our problem is 0.04 and it's weight, so it's going to be grams, and on the bottom it's going to be 100 ml. Now, for these ratio strength problems, our ratio is always going to be 1 to whatever. So this right here is going to be 1 gram. We can find out this to find out how many milliliters to find out our ratio strength. So we're going to do 0.04x is equal to 100 times 1. So by now we know 100 times 1 is 100, and we have 0.04x. We want to get rid of that, so 0.04 divided by 0.04 brings our x alone. And then we just need to divide 100 by 0.04, which is 2,500. So that our ratio strength is, and this is 2,500 ml, so 1 to 2,500. What is the ratio strength of a 0.01% weight volume solution? So we know our 0.01 is going to be grams over 100 ml, just like in the last example. And up here is going to be 1 grams. We just need to figure out this part to find out our ratio strength. So 0.01x is equal to 1 times 100, which is 100. I want to get x alone, so I need to divide this side by 0.01. Also this side by 0.01. So 100 divided by 0.01 is 10,000. So our ratio strength is 1 to 10,000. Percentage and ratio strength represent the amount of solute in a total amount of product. Percentage strength depicts the amount of active ingredient in 100 parts of total product. Ratio strength depicts 1 part of an active ingredient in a total amount of product. Ratio strength is most commonly used for weak solutions. Percentage is expressed using percent as an indication of the amount of active ingredient in a medication, and the ratio is divided by a colon to separate the solute in the solution.